Matters by GE. Our topic for today is Laws of Indices. Here are our objectives. Today we're going to be looking at 4 laws of indices. By the end of the video, you should be able to apply the zero index law, multiplication law, division law, and finally the power to power law. Let's begin. First thing, let's do a quick recap on indices. So, whenever we have repeated multiplication happening between one number, that's the expanded form. The index form is that shorthand way of representing repeated multiplication. And then we have the numerical form, which is the actual value. An index number has 2 parts. It has the base number and the exponent. For example, 10 squared, the base is 10, and the exponent or index or power is 2. The exponent tells us how often or how much times we multiply the base number by itself. All right, let's jump into it. Laws of indices. So laws of indices is just a way of manipulating expressions, but we can only apply these laws if the bases of the expression are the same. For example, 3 to the 4th power and 3 squared, we can use the law of indices because the bases are the same. But for the examples down here, 7 to the 4th power and 5 to the 2nd power, the bases are different. So we can't use the law of indices. You might ask, what are these laws of indices I am mentioning? Let's start with the first and the easiest to me, the zero index law. What that tells us is that once a number or any quantity raised to the power of 0, meaning the index or the exponent is 0, it will give you 1. The value is 1. All right, for example, 2 to the 0 power, that's 1. The multiplication law of indices tells us that whenever we're multiplying index numbers with the same base, we keep the base and add the powers or the exponents. For example, 5 times 5 to the 3rd power. I want you to note that whenever you see a base number without a written power above, we always assume that that power is 1. So 5, the power of this first 5 would be 1. So it's 5 to the 1 power times 5 to the 3rd power. Being that the bases are the same and we're multiplying, we're going to keep the 5. We're going to add the powers, which is 1 plus 3, and that will give us 4. And if we want to simplify even further, we could find the value of 5 to the 4th power. So the expanded form would be 5 times 5 times 5 times 5, and that will give us 3,125. Let's try some questions. Please pause the video and try these on your own. So 2 to the 6 times 2 to the 4th power, that would give us 2 to the 10th power. All we're doing is adding the powers and keeping the base. No matter what the base is, once they're the same, you keep it. And if you're multiplying, you add the power. So that would basically be 4 plus 2, which is 6. Next one would be 3 to the 12th power, and we realize that we have some coefficients here. We have 3 and 2. Because we're multiplying, we're going to multiply those coefficients, and that's going to give us 3 2s, 6. Now we have our base numbers. We're going to keep A, and we're going to add the 5 and the 7, and that's going to give us 12. Good job. Let's move on to the division law of indices. It tells us that when we're dividing index numbers that have the same base, we subtract the the power. And you know, there are different ways we can write division. We can either have the division sign, or it can be written in the form as a fraction. All we're going to do is keep the base. So we're keeping this 4, and we're going to subtract the power, which is 7 and 5, and that's going to give us 2. And that's the same thing we did for the fraction here. Powers are 7 and 2 for the x. We subtract, and we got x to the 5th power. Let us try some questions. Remember to pause the video. Good. So we're dividing. 6 into 24 goes 4 times. And what are we going to do to the powers when the bases are the same? Keep the base and subtract the power. So it's going to be 8 minus 4. And it's going to give us 4f to the 4th power. As easy as that. And we have division in fraction form. We're going to do the same thing. Whenever we have the coefficients, coefficients are simply the numbers that are in front of our variables. We're going to divide 2, 8 is 16, so 6 into 18 is 2. And what are we going to do with the powers for same bases? Keep the base and subtract the power. So this is 3 minus 2, that would be 1. And for the ends, you realize that the ends have a power of 1. So when they subtract, those ends will be eliminated. So our answer would be 2 to the m power. Or you could just put 2 to the m. Power to power law of indices. What this tells us is if you have a power raised to another power, all you do is multiply the powers. For example, we have 4 to the 7th power, all to the power of 5. So you realize this 4 to the 7th power is also to a power of 5. All you're going to do is keep the base, which is the 4, and multiply the powers. And 7 times 5 gives us 35. I want you to remember that every number and every letter has a power. So if you see a variable by itself, just know that it has a power of 1. You are correct. And if you have a number that is by itself, for example, you have 3, you're not seeing any power there, you always assume that the power is 1. Awesome. Let's look at this example. We have 2ab all to the power of 7. Remember, every number and every variable has a power. So this 2 has a power of 1, this a has a power of 1, and this b also has a power of 1. So all that we're going to do is take the power on the outside, which is the 7, and we're going to multiply it by all the powers within the bracket, keeping the base. So we're going to keep the 2. 7 times that 1 will give us 7. 7 times the 1 for the A will also give us 7. And 7 times the 1 for the B will give us 7 as well. And if you want, we can simplify even further. 2 to the power of 7, when we multiply 2 by itself 7 times, we will get 128. Let's try some questions. Remember to pause the video and give this a try. All right. So this 4 has a power of 1. And remember, the power on the outside is that 3. So we're going to take this 3 and multiply it by the powers on the inside of the bracket, but we're going to keep the base. So I like to write down the bases before. Write down my 4, write down my j. But I know that my powers are going to be different. 3 times the 1 on the 4 would give us 3. And 3 times the 8 on the j will give us 24. And if you want, you can simplify the 4 to the 3 further, but you don't need to. Our next question, we have 5k to the power of negative 3, all to the power of 4. So you tend to see brackets. So the 4 is the power on the outside. You're going to multiply it by the powers on the inside. That 5 has a power of 1 and the k has a power of -3. So we're going to multiply. 4 times 1 on the 5 will give us 4. And 4 times the -3 on the k will give us -12. And again, if you want to simplify 5 to the 4th power, which is 5 multiplied by itself 4 times, you can do that to get your final answer. Well done. All right, so guys, we have reached the end of our video. Remember to like, share, comment, and subscribe. Let's get the Math Matters channel to 150 subscribers. All right, so I hope to see you soon. Bye.